Number Theory, Section 2, Prime Numbers. Video 1, a prime number program. Python doesn't have a built-in function to check whether a number is prime or not, but this is something that you need during the course, so you have to be able to write your own program to determine whether a positive integer is prime. In this video, we're going to look at an example of the type of program that you could use. So here's the program. Let's look at it a section at a time. We start, as always, by defining our program and giving the function a name. So this function is called prime, and it takes a parameter which has been called n. So we're going to put in a number n and check to see if it's prime. Now this first part of the program here is a check to make sure that n is a whole number and that it is greater than 1, so that 2 is my lowest prime number. If my number isn't a whole number, or if my number is less than 2, I want it to say, no, this number is not prime, so it returns the value 0. The next part of the program defines a variable called result, which it sets equal to 1, and the result variable is going to be 1 for prime numbers and 0 for composite numbers. So I'm now saying I'm assuming I've got a prime number, and then this part of the code checks to see if that's actually true. If I don't have a prime number, then this bit of code will set the value of result here to be equal to 0. But if I do have a prime number, it'll never get to this line of code. Result will stay equal to 1, and then at the end of the program it returns result, so it returns 1 if it's prime and 0 if it's composite. Let's have a look at that in a Python shell window. So I start by defining my function, which I'm calling prime, and it takes parameter n, colon at the end of the line. Now, my first test is to make sure that my number is 2 or more and that it is a whole number. So if it's less than 2, or if it's not a whole number, I want the program to return a value of 0. Now, how do I check if something is a whole number? Well, one nice way is to say n, take away the integer part of n. So if this was a whole number, the integer part of n is the same as n. So imagine that n was equal to 6. 6, take away 6, is 0. But now imagine that instead we had something that wasn't a whole number, like 6.2, for example. 6.2, take away the integer part of 6.2, well, that's just 6. That leaves me with 0.2, which is not equal to 0. So if this gives me a value of 0, I've got a whole number. But if it's not equal to 0, then I have something which is not a whole number. So in the case that n is less than 2 or n is not a whole number, I want my function to return a value of 0. That's indented that part of the code, but then if the if statement isn't true, I want it to execute the next piece of code, which starts by saying our variable called result is equal to 1. Result is the thing which is keeping track of whether I've got a prime number or not. Now we're going to test to see if we do have a prime number. So for I in the range from 2 up to, and then this is a little bit complicated to explain, so let's look at it a little bit at a time. The integer part of n to the power of a half. So I'm going up to the square root of n, and that's usually not going to be a whole number, so I've taken the integer part of it. And then, as always, I'm adding 1 because I want to make sure that my last number is included in the range. Now you might want to think for a moment about why we've only gone up to the square root of n rather than going all the way up to n. What we're doing is we're going to divide by each number I up to the square root of n. And if it's a whole number, if it doesn't give me a remainder, then I know that I found a factor of n. If when I divide n by I get a remainder of 0. I know that I is a factor of n, so I know that n is not prime, so I set my result equal to 0. If I get all the way up to the square root of n and I haven't found a factor yet, I know that there's no need to carry on, because any factor which was bigger than the square root of n would have a corresponding factor smaller than the square root of n. I can now return the result, which will be 0 if it is not a prime and 1 if it's a prime. Let's test our program. Well, I happen to know that 17 is prime, so this should return a value of 1. And I happen to know that 24 is not a prime, so this should return a value of 0. So everything's looking good. In this video, you've learned how to write a function that checks whether a number is prime.